Hello everyone and welcome back to lesson 12, basic trigonometric identities. For this part of the lesson, we're going to discuss half angle identities. We will going to prove it and apply them. First, let's try to understand what is a half angle identity. Okay, so from the term half angle, so half of the angle. So for example, we have sine x over 2, so half of the angle, or cos x over 2, and we also have tan x over 2. So what are the identities or formulas that represent these half-angled function? Okay, so what are the formulas? So to understand, we're going to make use of our knowledge on the double angle identity. So to find the half angle formulas, we're going to use the double angle formulas. So where and how? So we'll start with the cosine, the idea of cosine 2x. Okay, so we can actually remember, or if we try to remember, we have cosine 2x equals 2 cos squared x minus 1. Okay, so our goal is to have a function, so at the left side of the equation, a function which does not contain the double angle. So we simply transfer. Okay, so we're going to transfer 1, so we'll have cos 2x minus, it's not minus anymore, but plus 1 equals 2 cos squared x. Okay, if we try to use symmetric property, so we know that this is the same as cos squared x equals cos 2x plus 1. Okay, divided by 2 both sides, so we will have cos squared x equals cos 2x plus 1 all over 2. Okay, but take note, our goal is not to have cos squared x. Our goal is to have cos of x over 2. Okay, so to do this, we simply divide 2 in our angle. So we will have cos squared x over 2. So using substitution, our x becomes x over 2. So we have 2 times x over 2. Okay, 2 times x over 2 plus 1 all over 2. Hence, we can cancel out 2 here, and we're left with, I'll just write it here. Okay, so we're left with cos squared x over 2 equals cos x plus 1, okay, over 2. Then we get the square root of both sides, because again our goal is to have cos x over 2. So we'll have cos x over 2 equals the square root, so it's positive negative. Okay, so positive negative square root of, I'll just write it as 1 plus cos x, okay, over 2. So we have our first formula. Okay, we have cos x over 2. So for cos x over 2, we have the square root of 1 plus cos x over 2. Okay, so we're done with cos of x over 2. So how about for sine? Okay, so we're going to look for sine x over 2. So it's the same process. We'll make use of cos 2x, but instead of using 2 cos squared x minus 1, we're going to use 1 minus 2 sine squared x. Okay, so the third form of cos 2x. Okay, so the same, we'll try to manipulate. So because we only want to have sine squared x. Okay, so if we use property of equality, we will have 2 sine squared x equals 1 minus cos 2x. Okay, and if we divide by 2, okay, so if we divide by 2 both sides, so we'll have sine squared x equals 1 minus cos 2x. 2 cos 2x all over 2. But again, we want to have a half angle. Okay, so to get the half angle, we simply divide the angle by 2. So we have sine of x over 2 equals 1 minus cos. So we have 2 here, but instead of x, so x is now x over 2, so we have x over 2 all over 2. Okay, so we will have, so cancel out 2 here. So we have now sine squared x over 2 equals 1 minus cos x over 2. But again, we're only looking for sine, not sine squared. Okay, so square root both sides, get the square root of 1 minus cos x over 2, and we'll have our final answer being sine, okay, so cancel out square, sine x over 2 equals positive negative square root of 1 minus cos x over 2. And this is our second half angle identity. Okay, so we have now sine and cosine, and we still need tangent. Okay, so to find tangent, we're going to use the idea of these two. Okay, sine and cosine. So again, we know that tangent theta is sine theta over cos theta. This is the quotient identity of tangent. So this implies that we have tan of x over 2 will have sine of x over 2 over cosine of x over 2. Okay, so if we continue this, substitute, so regardless of positive and negative, so let's just assume it's positive. So we have square root of 1 plus cos x over 2 all over, okay, all over square root of, so our cosine is 1 minus cos x over 2. Okay, now we can translate this one as, so take note that this bar here, the quotient here, or the over here, represents division. So we can actually write it as square root of 1 plus cos x over 2 divided by square root of 1 minus cos x over 2. Okay, but take note, if we apply laws of the law of radicals here, okay, so we can actually separate it. We have the square root of 1 plus cos x over square root of 2 divided by square root of 1 minus cos x over square root of 2. Okay, so take note that this is division. So if we try to divide, it's actually the reciprocal. So times the reciprocal of the denominator. So 1 plus cos x over square root of 2, so becomes times square root of 2 over square root of 1 minus cos x. Okay, and obviously we can see, obviously we can see a, we can cancel square root of 2. Okay, and we can combine. So after combining, we'll have square root of 1 plus cos x over square root of 1 minus cos x, or we can combine further square root. Okay, so positive negative, this is positive negative, square root of 1 plus cos x over 1 minus cos x, and this is the identity of tangent x over 2. So it's just the square root of 1 plus cos x over 1 minus cos x. To sum up, these are the half angle identities. So we have sine of theta over 2 equals the square root of 1 minus cos theta over 2. Then we have cos theta over 2 equals the square root of 1 plus cos theta over 2. And we have tangent theta over 2 equals the square root of 1 minus cos theta over 1 plus cos theta. Okay, so here's the tip in memorizing these three. So there is a pattern for sine and cosine. Okay, so if it's sine, it's minus. If it's cosine, it's plus. So they have the same form. Okay, then for tangent, since it's sine over cosine, so the sine here is the minus part, and the cosine is the cosine over cosine is 1 plus cos theta, which is this. Okay, so these are the half angle identities. Okay, so we're done with the concept. On the next video, we're going to have some examples involving half angle identities. See you there.